Hello friends, today we analyze the continuous beam, this ABC. In this case, here is the support B is sink by 48 divided by the EI. So this is a continuous beam. These are the loadings, AB span, BC span. Now always we know the first step is to find the kinematic indeterminacy KI. It is the unknown displacement. Now which are these? Now this A is support fixed, means there is no displacement. Support C is no displacement. Now this is internal support. So here is a possibility of the rotation like this here, like rotate. So we can take here Ki is equal to only 1, and that is the IB. So here only rotation at B is possible. Horizontally this is the hinge support, it is what not possible. Vertically there is a given is a sinking of support. So unknown displacement is only the here possibility of the rotation at the support B. This support is a fix, this support is a fix, so no rotation, no sinking. So here is the only possibility because of the hinge support, and always internal support have the rotation only. Now next step is the fixed end moments, that is we called as the FEM. So take span wise the span AB. Here the span AB, we now consider this as a fix. Consider each span as a fixed beam, A and B. Here already I have seen the fixed beam chapter, these develop like these moments. This is the M bar AB and this is M bar BA. So here M bar AB, so this is anti-clockwise, so minus for this loading from the fixed beam chapter, that is what formula is W L square by the 12. So this becomes the minus 108 kilonewton meter. Now M bar BA, so that is a plus WL square by 12 because this is the clockwise, so it is plus 108 kilonewton meter. Then take the span, BC. As per the procedure again, clamp both the ends, so restriction of the, now this is the force 3 meter. We know by the fixed beam these develop the fixed end moment like this, in the both are in the hogging nature, but here we are taking here the clockwise and anti-clockwise. So M bar BC is what? It is minus WAB square by L square. If you put the value, this will be the minus 42.18, and M bar CB, now this is the clockwise, so plus WA square B by L square. If you put here the value, this becomes plus 70.31 kilonewton meter. Now second step is over. Then go for the third step, and that is the slope deflection equation. Slope deflection equation here. So now again take the span wise, span AB. Now what here? Write the I is equal to, for this AB's I is equal to 3I, L is equal to the 9 meter, and important is the delta is the given. So delta for the AB total span, that is equal to, always if the span is AB, so always take first the leading joint minus the following joint. So always delta is the what? If the span is AB, so delta leading joint B minus A. If the span is BC, C minus B, in this way. So here delta B is what? 48 upon EI minus, here delta A is the 0, delta B is given as 48 upon the EI, delta C is equal to 0, only given is the delta B. So now we got here the 48 by EI. Now MAB. So we are writing the equation for SD equation for the span AB. So start with AB. So if AB, write here the M bar AB plus 2 EI by L into, first letter is A, so write here the IA plus IB minus, this is our routing procedure. Now here we know here the IA is 0 because of fixed end. Here IC is equal to 0 because of the fixed end. So this value becomes the 0. This value becomes the 0. Now M bar AB is minus 108 plus 2E. Here I is equal to 3I divided by L is 9 meter into the IB minus 3, delta is how much? 48 upon EI, so multiply by 48 divided by EI into L is the 9 meter. So if you rewrite here, minus 108 plus 2E into 3I divided by 9 in bracket is IA 0, so this is IB minus 3, delta is here 48 divided by EI, like this L is the 9 in this way. So minus 108 here, this becomes 2 by 3 EIIB minus, this becomes here what? 2 by 3 EI into 3 into 48 divided by EI into 9. So here this EI, this EI gets the cancel out. So this final value is minus 108 plus 2 by 3 EIIB minus, if you calculate this value, this becomes what? 2 by 3 into 3 into 48 divided by 9 . 2 by 3 into 3 into 48 divided by the 9. So this value is what? Is the 10 by 67. So now final equation is equal to minus, now this is minus and this is minus, so this becomes what? Plus 108, this becomes 118.67 plus 2 by 3 EIIB. This is equation number 1. Now the MBA, so that M bar BA procedure, BA M bar BA plus the twice EI by L. Here B is the starting point, so twice B plus I minus 3 delta by the L. Here we know IA is 0, so M bar BA, that is the plus 108 plus 2 E here. Again for the I, for the AB span is 3I divided by the 9 into twice IB minus here remaining is what? 3 delta by the L. So 108 plus this becomes what? 4 by 3 EIIB, and here minus this is the 2 by 3 EI into 3 into delta is 48 divided by the EI into 9. So this value is the same for the previous one. This value, this always for the one span, this delta value, both the values are always the same for the one span. So this becomes 108 4 by 3 EIIB minus 10.67. So this becomes 108 minus 10.67. So this becomes 97.33 plus 4 by 3 EIIB. Equation number is 2. Then go to the second span here. Now this is important. The span BC. Here L is equal to 8 meter. I is equal to I by this I is equal to I. Now delta, important is here. Delta is equal to, so BC. So take the leading edge first, leading joint. Delta C minus the following joint. So here we can say that is equal to here. Delta C here is a 0 because not given, only delta B is the given. So this 0 minus 48 divided by EI. So here delta becomes minus 48 by EI. So now MBC is equal to M bar BC as per procedure twice EI by L into twice IB plus the IC minus 3 delta by L. Now here important is what? M bar BC is how much is M bar BC? Minus 42.18 plus here 2E I is equal to I. L is the 8 meter. So in bracket here we know this IC 0 twice IB minus 3 delta by the L. Then minus 42.18 plus here is EI by 4 into twice IB minus, now what here? Put here value 2 EI by 8 into 3 by length is 8 meter, delta is minus 48 by EI. So this minus become the plus, then this EI and this EI get the cancel out. So minus 48.18 plus EIIB divided by 2 minus this value becomes the here 2 by 8 into 3 divided by 8 into 48. So this becomes 4.5. So this becomes plus 4.5 with this minus, and this minus becomes the plus. So here we can say that is a final value minus 48.18 plus 4.5, this is 43.68. So minus 43.68 plus 0.5 EIB is equation number 3. Now last equation, here MCB is equal to M bar CB plus the twice EI by L into twice IC plus IB minus 3 delta by L. We know here this IC is 0 because this IC is what? 0 because of the fixed end. Now M bar CB is how much is? Plus 70.31 plus 2E. Now here the I is equal to I, already we have written here I is equal to I, so I divided by 8 into IB minus 3 delta by the L. Now put the value, it becomes 70.31 plus the EIIB divided by 4, and always this value is same for the both BC and CB. Again we calculate here, suppose is minus 2EI divided by 8 into 3 by 8, L is 8, into minus 48 upon EI. So this value is always the same, and that is this minus is plus, and this total value is a 4.5. So 70.31 plus 0.25 EIIB plus the 4.5. So this becomes 74.81 plus 0.25 EIIB. Equation number 4. Now apply equilibrium condition. Now which are these conditions here? Now we have already seen in the many of the lectures, if this is the displacement is the IB, so your condition is the sigma MB is equal to 0. If this is IC, then sigma MC equal to 0. If this is IA, so sigma I is equal to 0. So sigma MB is equal to 0. So at the joint B, how many the moments at the joint B? Look here, BA and BC. So we can say that sigma MB is MBA plus MBC, that is equal to 0. So MBA is here 97.33 plus 4 by 3 EIIB BA, and BC is minus 43.68 plus 0.5 EIIB, that is equal to 0. Here is the algebraic sum of the BA and BC. So if you calculate this becomes the 4 by 3, this and this plus, this becomes the 11 by 6 EIIB is equal to, this becomes the minus, this become plus, so this minus 97.33. So this value is the $53.65. So IB is equal to minus, this is minus 53.65 into 6 divided by 11. So this becomes minus 29.26. So we got the value here, unknown displacement. Now put this value in equation 1, 2, 3 and 4 and find the final fixed end moment. So we are putting this value. Now here we kept this value here, in here the EIB in this equation, EIB in this equation, EIB in this equation. So if this calculate, this MAB is minus 138, then MBA is plus 58.31 and MBC is, so this is what, sigma MB is equal to 0. So here sigma MB is 0 because this is minus, this is plus, total should be the 0 as per the conditions. Now next is the draw the bend moment diagram here. For the first, consider each span as a simply supported and draw the bend moment diagram. So if here the WL square by 8, WL square by 8, W square by 9, WL square by 8 here, yes. We got this value is 162 and here WAB by L, this is a 112 is something here. Considering each span as a simply supported and find the bend moment. Now superimpose the bend moment diagram here. Now how to superimpose? Now this is what is minus. Minus means is anti-clockwise. Anti-clockwise means this like this. So this creates the hogging bend moment. So here is create the hogging bend moment like this. So draw here is 138. Then at the joint B, this is plus, this is minus, means this is a plus 58.31 and here is a minus 58.31. So this try to push the upward side. So this type of sign is what? Hogging bend moment. That is the 58.31. Here is a 138.17 kilonewton meter. This is a kilonewton meter. Then last here what? This is the plus. Plus means clockwise. So apply here the clockwise. So this try to push this upward. So that is why is a hogging. So 67 is something here. This is 67.49. Now join these points all here. Suppose something here down. In this way. This is the final BMD. Now this part is minus, this part is minus, this part is minus. Above the line is plus, and this common part gets the cancel out. This is the combined BMD. Thank you.